like to introduce my two teammates, Louis and Claudio. Louis works with me at Satori, Claudio is at Esri. And what we're going to do in the next half an hour, and we're going to break at 11:15 for that promised half an hour break. What we're going to do is show you a little bit of some beautiful pictures. I love this part of what we do, which is measuring and digitizing the existing world. So yesterday in our intro, Khaled talked about the fact that so much of our world is already built. And so we responded to that reality by saying, well, if it's already built, it means that there's opportunity for us to influence what's already built. We need to find a way to do that consistently. And so Louis and I have spent quite a lot of time figuring out how to do that and make that systematic in our business. So, let's talk workflow. As with all of our processes, we started by saying, okay, cool, we can do a lot of smart stuff with technology, but how do we do it well? And so we went through a process of about 5 years of experimenting and making some monumental mistakes in some cases, but also getting a lot of information to experiment with. And we are very happy to share that with anyone who would like to learn how do they avoid the learning curve and get on the front foot with this type of technology. The fact is, the amount of existing buildings in South Africa alone that are totally undocumented is staggering. If we take millions and millions and millions and millions of square meters of buildings that are in the public domain, that are unmeasured, undocumented, or are documented and out of date, it's crazy. So if we talk about BIM without understanding how we are going to catch up that backlog, we're fooling ourselves. So we said, okay, how do we use technology to do that? Then we looked at the technology and we realized there's some really expensive tech out there, which is excellent, and there's some less expensive tech. And we said, right, we can't afford the expensive stuff, so let's see how much we can do with the cheap stuff. So we started off by buying a Phantom 4 drone. Before that, we had a Phantom 3. A Phantom 4 at the time cost 30,000 Rand, and we bought some extra batteries, and we flew it around, and we took photos of things. We took photos of buildings, of construction sites. We used software, and we pulled that into our computers, and we thought, this is amazing. Then we realized that we needed base points. So we started working with surveyors, and we figured out how to plan the location of those surface areas to put base points in that we could then take that data set and put it exactly in the right place, as we heard yesterday. Then we went inside buildings and we said, okay, there are industrial grade scanners that sit on tripods that give excellent results, but it's not really our thing. So we started experimenting with mobile scanners, and we used about 4 different types. We borrowed them, we rented them, we bought one, and started comparing those results. We worked with the university, who's also got a different brand. We compared those results and figured out what does it take to measure the inside of a building reliably, good enough for architectural purposes, good enough for planning and facilities management. And all of that experimentation then resulted in this plan. And this is how we work on all of our projects when we need to go and collect information because there isn't. And then at least we can get ourselves from no information to good enough to plan, good enough to get the ball rolling in the shortest amount of time. We always start off in the survey world. We always start off by making sure that we've got reliable base points, because otherwise our information is meaningless. It's just hovering around. We work with surveyors when it matters. In other words, if we need that centimeter accuracy. If it's not that important, if more or less is good enough, we've got GPS equipment that we've learned to use. Then, when we need to see things from the sky, we fly our drones. We are an operator, we've got licensing requirements in South Africa, and outside of the continent, there are many companies that are licensed to fly, and we bring them into our teams and say, please go and capture these images. And whatever we capture, videos and photographs, we're able to then process into 3D meshes, photographs, and point clouds. And Louis is going to show us what some of those things looks like. Inside buildings, we use a variety of scanning technologies to measure the insides of the buildings. It produces massive data sets, which we then need to very cleverly manipulate to get them small enough to be useful, but still clear enough to identify the insides of those buildings. All of that gets then combined using software into a picture that we can share with the architect team, with the building services team, with the structural team, and they can then use that as a starting point. What's interesting is this is not replacing the world of survey. What it's doing is it's filling in gaps where you need to describe what the world looks like so that you can think about it. If you can visualize a situation, you can visualize a solution for a practical issue in that situation, and that's what this technology enables us to do. Then following that process, we can bring all of that information into a computer environment that can be shared. One of the biggest challenges with information that's big is it's hard to bring everyone into that space. And that's where we've used technologies like Esri's geospatial platforms to put that in a place where everyone can be invited that needs to see that, and they can use an internet site for that project to actually look at the information, switch things on and off, and everyone in the project can use that information to understand what does that project actually look like, what does it involve, what are the physical constraints, what is the context of the project. So that is the workflow that we've put together. On the bottom side over there, you can see a building that might look familiar to some of you. It's the Bokende building that we spoke about yesterday. And directly above it is a point cloud. Yesterday we spoke about point clouds, and a few people in the room said they hadn't actually seen what these things look like. So I'm going to hand over to Louis, who's going to take us through a couple of examples of things. I'm not sure exactly what sequence he's going to show us in, but he's going to give you some insight into what this stuff looks like and what it is like to actually work with them.
Thanks, Richard. All right, so let's hope all of this works because we are not doing presentations. So that was our slide for now. And you know, sometimes the technology and the software has got a way of letting you down. Anyway, so like Richard said, this is, maybe that's the wrong one I actually started on. So what we normally do is we start on the outside. We understand what does the site look like, what is there, and the first thing we do is put a drone in the air. So Richard mentioned those 30,000 Rand Phantoms. We still fly them. It's been 6 years and we haven't really upgraded that tech yet. We have now gone for the latest kind of M3 with RTK, which adds in the accuracy part. But really using standard technology, we've really stress tested the technology. So a lot of time people think the stuff that we do and everything I'm going to show you now is still with those Phantoms. So they do really perform well if you know how to use them well, and that's really where we've spent our time. So in terms of drone photogrammetry, some of you might know about how it works, some might not, but basically we program the drone to fly a fixed path, taking photos at fixed intervals, and then put it into a computer that's got some serious processing power, and it creates a 3D mesh or a 3D point cloud and a 2D ortho, and that goes into the design packages. So the first thing for us is really just understanding what does this world look like. Each of these green dots you see there is a photo that was taken, and something like this typically takes us, let's say, give or take an hour to fly. So it's quite a rapid collection, and within a day of running the computer and processing, you actually have something you can look at. What does that facility look like? So if we go to Bokende, you can kind of see what the building looks like. You can start to understand the environment. So if we had to do a job here, what does it look like? Where are the vegetation and so on? We can also from here do initial condition assessments. We don't really do the full on thing, but we get an idea of what is the extent, and from there we can also plan that next phase. So this is capturing the outside. From there we move on to the inside. So this is a point cloud. If I zoom in, you'll see, and you get different scanners that provide different types of point clouds. Like Richard said, we've kind of settled on the in-house suite is the mobile, the SLAM scanners. So you walk around with them, where with a traditional stationary scanner, you've got to put it down and get around all of the corners, which is great when you need that absolute detail, that high detail, if we're doing pipe connections or fixes to tanks in a fuel terminal or those kind of things, and then we use those scanners. But for general architecture and capturing the world, we find that these scanners provide good enough detail for that. We do that together with, again, a control system, so targets, whether it's inside the building or outside the building, depending on the type of scanner. And then we can also coordinate all of this data so that it sits in the real location. So typically something like this, we took our in this case the Leica scanners, the SLAM scanners, and we scanned this building in under 2 hours. All the floors, the basements, and everything else, and we've got now a picture of what does this building actually look like. What's great about this, it also generates these photos. So if a modeler now needs to look at this information and start to model it, sometimes within the point cloud, it can be, sorry, I want to click on that thing and not browse. It can be sometimes a bit unclear exactly what are they looking at, what type of light fitting is it, and with this, we've got the ability, now I didn't choose the best one, but we've actually got the ability to go into a 360 image and start to look at what does it look like. Oh, it is a cable tray, or it is a fire hydrant, or what is it actually that we are looking at in that point cloud. And this provides us the opportunity to then navigate this building, understand it, see what's there, and the modelers can take this into their applications like Revit and their design packages. The challenges we find with these kind of things is that a high-spec computer like this runs this quite easily. When you push it into the rest of your teams and they don't have the same kind of computing power, they struggle to work with it. So it's part of the workflow is also figuring out what is enough detail for them to use. We've talked about it, how do we break up this information when we scan large facilities, 40,000 squares, how do we break that thing up so that people can actually work with the data and they don't spend hours waiting for things to load. And then this typically gets turned into a model. So I want to give over to Claudio to just show you what this looks like when we put it together in the Esri environment, and then I'll show you in one of our packages again what it looks like.
Great. Thanks, Dave. Good morning, all. All right, so from what we can see, this is a typical view, right? I think even on your navigation, on your smartphone, if you switch from the one reference image to this image, you kind of see a shot from above, right? But I think the importance of a scan-to-BIM workflow is not just about collecting the data, but when it comes to analyses, what that really means is how do you get insights out of this, right? So we know we have data, gets processed into information. The more context you add, the more information pieces you put together, you start getting knowledge, and from there, that intelligence actually drives how you can make decisions. All right, so just as an example over here, we can see the campus is in a two-dimensional space. So if we switch to kind of the 3D space of this, right, so now this is taking the point cloud, so which was previously shown, overlaid with the aerial imagery as well, right, so it creates a realistic picture. So again, this is a form of reality capture. Let me just get back to that. There we go. Right, so as we start navigating around this, there is some analyses we can run as well. So again, analyses, painting a scenario, a real life question that you could be wanting to ask, and using a data-driven response to help guide that decision best. So as an example, you'll all be familiar with the load shedding situation and the drive for solar panels, so embedded generation. So as an example for this, some of the analyses you could drive off this is actually doing classification, right, to see what is the aspect, what is the direction of the roof, bringing in a different data set which gives you the solar radiation. Now we start painting a different picture, right? We start putting this all on top of each other. How many hours of sunlight typically am I going to look if I have to position a solar panel there, and there, or if I needed to increase the capacity, right? So these are some of the considerations we can bring about. So within this environment as well, another typical type of scenario we see is not only being able to do the measurements, right? I think that's pretty typical in what you get in the 3D space. But where this can become practical is example, where do I position my security cameras outside of the building, right? We know they all have a certain type of reach. So at what height and what is the line of sight that it would see, right? So these are the type of interactive, almost modeling real life scenarios to see, okay, if I put it at a certain height and at a certain angle, it's going to capture this amount of space, right? So before even someone's even gone and gotten a quote for these security cameras, never mind how many cameras, you can start interacting with this reality capture to help supplement that decision at the end of the day. All right, so there are some other tools as well, specifically to, if you want to see the inside of the building, slice through it versus seeing the externals as well. But I think just a final thing, I would say that with all these technologies, specifically, I know I can speak from our platform, there's a lot of different tools. The big thing is having a finite business question, right? What do you want to get out of your model? What do you want to understand better? So, because what you're getting from this is not just understanding the building, you're seeing how it interacts within its natural and built environment, right? So a grander picture of it, looking at it in a bigger scheme of things. So I think I'm just going to hand over back to, I think, Louis to take us through the civil part of it. Yeah. Correct? Great.
Great, thanks. Yeah, so what we've also done with this specific one is, like I said, access to information. So we can also actually in their platform load in the 3D models, so people can actually view what does this model going to look like in that environment and put that information all together, because sharing the information is one of the biggest challenges we actually find. The same kind of thing we can do in other environments. So if we go into some of the packages that we use, we can start to pull in all of this information, the scan information, the drone information, the building model, and see, does it actually all fit together? Was the coordination correctly done? And we can start to look at things like this, where we can actually start to isolate parts of it, or we can see how does all of this look together when we do like a federation. When we put it together, does everything fit? And there is some small niggles with this model, so don't look in too much detail. But we can all of a sudden see how the inside walls, the outside walls, and everything fits together. What's great about this, and where we've used it a few times as well, is we don't necessarily have to model everything. So if we've got a model and we've got the scan information, because it's overlaid, we can actually see how does the furniture look in that space, what space is still available. So we've also looked at workflows where we don't have to remodel everything that's not going to change, but just model what's actually necessary, and then integrate the different types of data to also save some time. Yeah, and then I think the other thing is how do we start using this in other environments? So while we're in these kind of packages, this is something we're currently working on. For instance, is what is it in English? Now I've lost my words. Krans.
It's an irrigation canal in the Eastern Cape.
Yes.
And the canal at the bottom there, if Louis just tilts the image down, you'll see it in cross-section. That cliff is starting to collapse. And so the geotechnical engineers need to understand, what does that rock actually look like? So that instead of having to climb up and down the mountain, which is very dangerous, they can actually go and do a close-up inspection of the rock, what it looked like last week, and start planning the anchoring systems to fix that. So from a safety perspective, it's fantastic. We don't have to have people risking their lives, in this case, with climbing up a 30-meter high cliff to have a look at what it looks like there.
And yeah, just again, we did this using those 6-year-old Phantom 4s, and in 2 days on site. So that's really the beauty of this, and this goes into these design packages where they analyze, like Richard said, analyze all of the information. But we've also looked at, so I come from a roads background, I mentioned it yesterday, so I'm also kind of, my frustration a lot of times is when you say the word BIM, people look at you and go, well, I'm not doing buildings, so it's got nothing to do with me. So we try and work towards changing that kind of environment as well. So if you look at something like this, those of you that's from Pretoria will know this hole next to the road, causing frustration, close to the R21. And now what we've done there is also doing construction monitoring. You see, this is where it gets to the fun part when you do live things. Is actually using the drones to start to map out that environment, to see what did it look like initially, how do things change over time. So out of a contract management perspective, we can actually see what has happened. So what did it look like, how did it look the month after that, and 2 months later, what is actually happening on site. But together with that, we can also start to see, are things happening in the right place? So if we start putting in where is the excavation, for instance, supposed to be, we can actually see, are they in the right place? So putting that information together, where people used to have these various KMZ files being emailed around and pulled into their own version of Google Earth, and then they're not sure which version is the correct one, we can actually start to put all of this information together for them to see where were things, where were the piles, where was the edge of the road. So putting information together, but also being able to compare these kind of things. A different one that we did was, and Richard briefly mentioned this, was in the COVID time. So shortly after people were allowed to move around, this project went out to tender, and we were stuck with the challenge is to get everybody into the Transkei, which already only has about 2 places to stay at. How do you get all of the major contractors there to see the site, to understand what they need to build in this 15 kilometers of basically green fields? There is a dirt track, but it's not like close to a highway. And how do we do that? So we figured, let's build a digital tender briefing. And since we've actually done a few of them, and we went down to site, and again, it's about the data, so it's not always necessarily drones. In this case, we actually hired people with an airplane to say, we need quite a wide area covered. Bring an airplane, come fly this thing for us, and process the data in the same way. And then we took the designs, we overlaid it, and we made this viewer available to all of the contractors to say, there you go, you can exactly now see what's happening, what's the influence, which properties are going to be affected, where's the power lines, where's the cuttings, what does the area look like. And one of the interesting things, what the feedback from the team was, they actually had very little queries and questions from the contractors, because all of a sudden they had a lot more information than quickly driving over the site on ground level and not being able to see everything. Now they could see 3 properties deep, what does it look like? Where are they? And we brought in all of the haul roads and all of that information that they could understand what it looks like. And even in this viewer, you've got the ability to click on something and it will tell you, once it loads, it's a yellow line. So it's got those properties. And I think for the modelers out there, that's one of our biggest frustrations, is when we start to visualize the data, when we bring it into the Esri environment, and you want to visualize the building, and it's a 3-story building, and the thing tells you it's got 17 levels, because things are drawn on the wrong level. So teaching people to really follow the right process, do things correctly, means that we can use that data downstream without additional rework. Don't know if you've got anything to add at this point, otherwise I'll carry on. So we've done this. One of the other ones in terms of so a lot of you might know as-built processes, so I actually don't have a current example I can show due to restrictions, but we've started doing quite a few as-built scanning projects now, where we scan as well as things happen, before ceilings get closed, before floors get closed off, because then we can compare that with the models and see, were things actually built in the right place, was everything captured on the as-builts. And the same goes for construction again. If we look at infrastructure, so this is the extension to the Ford factory. So anybody that might drive a next-gen Ford, these things come out of this factory. So we started this project when there was nothing. Also in the COVID times, you'll see there June 2020. And as things happened on site, we captured this every week, every second week, continued capturing this project. What is interesting about this, and there's a nice example I like to actually show, which, let me just find sorry, there's so much information. So we get to a point where we start to close services again. So pipes are being installed underground, sleeves are installed, and stormwater networks, water networks, everything gets installed. And the buildings are up, roofs are up, and if you zoom into a specific part here, what you will see at some point when the project is completed is there's this like concrete slab. And everybody will know that's worked on a site. Now, to get that thing open, you need a special key. You need somebody with a pick or something that can now pick up that heavy lid, and then you can maybe see on the inside what's happening there. So in the digital world, what's great is we can now actually go back until we see that it's open. So there we see, okay, lid's off, and we can see, okay, there's 3 valves. They're going in some direction, so two going left and right and one across the road, so we can make assumptions about where these pipes now possibly are, and we can assume they may be running over the sidewalks, running over to that island and crossing the road, or going over, straight. And so we can pull back the information until a point where we can, let's just see if this thing is actually loading now. Didn't I switch off there? Sorry. We can see there, we pull it back, and it's still open, and now we can start to see more. So we can see all of a sudden, those pipes actually turned. So there's a slight bend in it, and maybe just look one more back, and we can actually see how far the bends are, where these pipes are actually located. On the same project now, already under operation, additional service providers are installing services like fiber and networks like that, looking for sleeves. And at some point they were looking for sleeves, they found 3, but there's supposed to be 8. And we started looking at the data, and we could actually tell them, dig 500 mils deeper, and you'll find the other 5. Because they were installed on top of each other. So we could actually see that in the information. So there's a lot of value in capturing this kind of information. We can overlay designs. We've done that on quite a few projects where we've got a case where quite a few years ago as well on where they were building a fill, where Richard was doing the drone work at the time and overlaying designs, and they actually realized the fill was built too narrow. And they could pick that up early enough that it didn't have an influence on the project. So there's a lot of things that we're doing in this space. My other hat is digital construction, and I think it's something we can maybe touch on at some point. But yeah, for today, this is what we tend to do in reality capture, and it's really measuring the world using standard technologies. But you don't always need the most expensive drone or the biggest drone or the highest detail scanner. There's a lot of technology out there that can get you going.
And I think really it underscores the importance of workflow. The technology wouldn't have done this if we hadn't structured it in a very specific workflow. And secondly, understanding then how does this information add value back to the project. And that's another area where as an industry, I think we're still very young as an industry, is realizing that this is not just a weird special feature that some people do, but it actually becomes a layer of information that we want to bring into the BIM workflows to say, if we can use reality capture to understand the world, how do we work that into the broader workflows on a project?
Richard, can I quickly go through this one? So we've got one other interesting one that we did a while back, where somebody approached us about a heritage site, and they said they want to use a drone to capture it. I was not convinced at the time, and I said, but it's fine, let's do it. We'll put a drone in the air, and we used a different drone this time. We got a subby with a specific craft, so a M300 with a LiDAR unit, and we did photogrammetry at the time, and we flew the site, and this is what we saw. And I was like, okay, well, great. Trees, dirt, and then we started analyzing this information, and you zoom into it, and it might not be so clear there, but you start zooming in, and you actually start to see, okay, there's some footprints of things in between the bushes. And then we started looking at the LiDAR information, and we could actually start to see these, what actually transpired there, and created these surfaces. And together with the archaeologist, we visited the site, walked around, looked at things, and we actually brought our visualization team into this, and they recreated these renders based on that. Using those actual footprints in their software, they created these renders of that heritage area. And so there was a bit of a different use for the technology, but and I just thought I'd put this in here. I know it's not completely the heritage BIM that Gallade is referring to in terms of what they're doing with the library building, but it's at least a part of, it's touching on that kind of thing in the normal engineering world as well. So yeah.